Hello, brilliant minds, and welcome back to your physics buddy. We are starting a brand new essential unit work, energy, and power. This series is the backbone of physics, and mastering it will unlock countless concepts of your AP Physics as well as Honors Physics exam. In this lecture, we are kicking off with a specific work, will define work, and will also break down from the ground up. Make sure you subscribe to the channel and hit the bell notification for the entire series. Stay tuned, let's do this.
All right, then let's start our today's session. So basically, this is going to be Unit 7,
Yep.
in which we'll talk about work, energy, and power. Now, first of all, we need to understand that all these terms are interrelated. You cannot understand the second term without understanding the first one. So we have to start with work here, that what exactly work is. So work is defined as force times displacement. Like how can we explain it? For example, suppose that there is an object and that object was initially at rest, I assume. So now what happens is we apply force from the backward side, from the opposite direction, and because of the force acting on the body, the object is going to move, or you can say it is going to displace in this direction. So what we need to understand here is that work is only defined when there is a force, and because of that force, there is some displacement going on. The work mathematically can be expressed as force times displacement. Or you can write work is nothing but product of force and displacement. What we need to understand here is that work is a scalar quantity.
Mhm.
So all the properties of scalars will be applicable here, as well as we talk about its unit. Its unit is defined as Newton meters, or we also call it joules. Now the most important part here is that according to work, it is only defined when either force is acting in the direction of displacement, when either force is acting in the direction of displacement, or when displacement is acting in the direction of force. So let us understand what does it mean. For example, suppose there is an object and that object experiences force in this direction, such that with the horizontal, it is making some angle theta, I assume. Assuming the mass of the object to be m, when the force is acting on this direction, what we will observe here is that object is going to move in the horizontal direction. So what we have to do is, according to work energy theorem, according to work, we have to find work. Either this force should be in the direction of displacement, and if you just try to understand what is the force in the direction of displacement, it is going to be F cos theta. Similarly, either displacement in the direction of force, which can be written as S cos theta. So the conclusive part here is that work is either force in the direction of displacement or displacement in the direction of force. So force in the direction of displacement can be written as F cos theta times displacement, or we can also write as displacement as S cos theta in the direction of displacement, direction of force. So what we exactly have here is that work is defined as force times displacement times cos of angle between the force and displacement. This is the most important part about work. Work is only defined when we are talking about force or displacement in the direction of, again, displacement and force. So as we know, as we already studied vectors, we define that if there is anything is multiplied by cos, it means that it must be dot product. So work is the dot product between force and displacement. So this is that one thing that you need to keep in your mind. Now what we have to understand here is that there are few cases. We can also call them as some special cases. So in the very first case, when force and displacement having some angle between them such that theta lies between 0 to 90 degree. Now what will happen here is, because of this theta, this is what we have to understand. So if you just look at the diagram of the force and displacement, so we can assume that if displacement is taking place in this direction, so force must be acting at some angle theta. And if this theta is ranging, or we can say if it lies between 0 to 90 degree, what we can understand here is that work is going to be Fs cos theta, and whatever value of cos theta we are going to get, as theta lies between 0 and 90 degree, the value of cos theta is going to be positive. Therefore, cos theta must be positive, and if it is positive, work is going to be positive. So this is the most important case about work left, that in which case we can actually call that work is going to be positive. So work is going to be positive when theta is going to be lying between 0 to 90 degree. What we need to understand from this particular part here is, like, if force or component of force is acting in the direction of displacement, then work is going to be positive. Then work is going to be positive. And this positive work defines one important thing. This positive work defines that force and displacement are in same direction. Now just think and tell me, if force and displacement are acting in the opposite directions, or force is acting at some angle more than 90 degree, now what is going to happen? In that case, if force is acting at some other angle more than 90 degree, let's say this is how force is acting, and this is how displacement is taking place. So in this case, if we define theta must lies between 90 degree and 180 degrees. So in that case, we are going to get negative work.
Yeah, okay. That's what I was gonna say.
Yeah. So the second case here we have is the case of negative work, in which force and displacement must be acting opposite to each other. Like, in whatever direction force is acting, displacement is taking place in opposite direction. As we know, work is Fs cos theta, and we know if cos theta lies between 90 and 180 degree, it is going to be negative. So this will give us negative work. Now let us try to imagine those situations where the work by a given force can be negative. The one such example here we have is the example of a car moving in a straight line applying brakes. Like, for example, initially the car was moving a certain velocity in this direction. Now what happens here is the driver applies the brake. So when driver is actually applying the brake, the force will act in the backward direction. This is what we can say. And this is the ideal case which represents that force is acting in such a way that it will help this vehicle to stop. Or you can say, here in this case, the force is acting in the backward direction where the displacement is taking place in the forward direction. So in this case, theta is going to be 180 degree. What is this theta? Angle between force and displacement.
Yeah.
This angle between force and displacement, as it is going to be 180 degree, and we know that cos 180 is nothing but negative 1. So work in this case by the force is going to be negative Fs. So this is one such scenario where we can actually observe and force is acting in the opposite direction of displacement. So this will give us negative work, and this is how we are supposed to see it. So always remember, whenever you are solving any question of work, what you have to find, first of all, you have to see the direction of motion, that in which direction our object is actually moving. Once you're done with the direction of motion thing, you need to actually see that in which direction force is acting. So in whichever direction force is acting, you have to consider the angle between the force and displacement. In multiple cases, it is going to be different. Apart from this, we have another case, and that case is of zero work. So this is a very specific one. So we can say when force is acting perpendicular to the displacement. In this case, work is going to be zero. Like for example, suppose there is an object, it is displacing in this direction, and force is acting this way. So force is acting in such a way that the angle between them is 90 degree. So if angle between them is 90 degree, work is going to be Fs cos 90. And we know that the value of cos 90 is 0. So work we are getting here because of that force will come out as 0. So what you have to understand here is that whenever we are calculating work, whenever we are calculating work, force and displacement must have component in each other's direction. If there is a component in each other's direction, then we will say that work must be done due to given force. So this is the most important part. Work is only there if either force is in the direction of displacement or direction is in the displacement is in the direction of force.
Um,
In all the cases, you just have to visualize that in which direction force is acting and in which direction work is going on, or like displacement is going on. Now let us try to understand the physical significance of this zero work. So just imagine there is a person and he is carrying something over his head. This particular mass has some weight m, I can assume, and the most important thing is that the person is moving in the forward direction. So if you just try to understand that what is the work done by gravity in this case, if we try to understand work done by gravity, so that is coming out to be 0.
mhm.
Because mg must be acting in the downward direction, so force must have its downward direction, whereas the displacement is in forward direction. So angle between them is 90 degrees, so work is going to be 0 because of gravity. So this is one such case where this whole thing is applicable of 0 work. Apart from this, we have to actually see that how we can actually calculate the work. So let me just take a very simple example. Just try to find it out what is going to be work in the given case. So the question is pretty simple. The question says that the object is initially moving with 20 meters per second. Constant force of 100 newtons acts in the back from the backward direction. Question is find work done by given force in 5 seconds.
Yeah.
So how we are supposed to do it? Let us understand. And the next one you'll be going to do. So what we have understood here is that work is nothing but it is force times displacement and cos of theta between them. So as we can see here, as the object was moving initially towards right, 20 meters per second. So a force acts in the back from the backward direction in the same direction of motion. So if it is acting in the same direction of motion, let us consider this as case 1. Force acting in the direction of the initial motion. Force acting in the direction of initial velocity. So how can we say that? How can we find out work here? The work is going to be force times displacement times cos of 0, because force and displacement both are in same direction.
Yeah.
So work is simply calculated by force times displacement. Now the most important part here is that we have to understand how can we calculate displacement here. So as you
Mhm.
already know, this particular thing has some initial velocity 20 meters per second, Apart from this, what should be the acceleration of this body, assuming this mass is 5 kgs? So how can we find out the acceleration of the system? By simply using second law of motion. And according to second law of motion, force is mass times acceleration. So acceleration is going to be force upon mass. Force is 100 newtons, mass is supposed to be 5 kg. So acceleration we are going to have here is 20 meters per second square. We got the acceleration, we have the initial velocity, we have the time here. We can simply find out displacement using second equation of motion. So we can say using second equation of motion, force, because of the force, particle have some acceleration 20 meters per second square. So displacement S is going to be initial velocity times t plus half of acceleration times t square. So displacement in this case within 5 seconds is coming out to be 20 times 5 plus half of acceleration is going to be 20 times t square, that is 5 square. So 100 plus 10 times 25. So 100 plus 250. The displacement is coming out to be 350 meters. We have to find out work. Work is going to be 100 times 350 meters, which is going to be 35000 joules. So this is how you are supposed to find it out, like the work. Always remember, whatever question is given to you, just have to make sure work is simply calculated by Fs. So you have to figure it out how F is calculated. You have to figure it out how S is given. You just solve it, you'll get the answer. Similarly, let me assume the case 2. This is an interesting one. So in case 2, I assume force is acting in the opposite direction of initial velocity. The force is acting in opposite direction of initial velocity. Like, what does it mean? This is my object. It was going in this direction with 20 meters per second. The force we have applied in this direction, that too of 100 newtons, assuming the same thing, mass is of 5 kg. So the question is again the same one. Find out the work for the given case. Try it out. Think about it. Just keep the first case in mind and think about it and tell me how the second case can be solved. Try it out and tell me.
Okay. We use the first equation of motion.
First of all, tell me what is the acceleration you got?
20 meters per second.
Square. So try to find out the displacement first and simply multiply the displacement with force, but it is going to be negative because work is going to be negative here because displacement must be taking place in the forward direction because of the initial velocity, whereas we have to find out the work. So in the first, if we assume the direction of acceleration as well, so using second equation of motion, we can find out the displacement, which is going to be S is equals to initial velocity times time plus half of acceleration times t square. So initial velocity is 20 meters per second. The time is 5 seconds as it was mentioned in the first part. Acceleration is going to be 5, negative 5. Time is going to be 5 square. Sorry, acceleration is going to be negative 20. So if you try to solve it, what you are going to get? 100 minus 250. So displacement here which you are getting is negative 150 meters. Like for example, because of the given force, object must be moving this way. Like it started from this particular point, it traveled forward 100 meters, then it traveled in the backward direction 250 meters because of the application of force. So in the main case, the net displacement is going to be 150 meters. So in this case, if we try to find out the work is going to be force times displacement times cos of angle between them. Initially, the direction of force is the backward and the displacement is in the forward direction, so the angle is going to be 180 degrees. We find out force is 100, it is given in the question, displacement is 150 meters, and the displacement angle, it is going to be negative 1. So work is going to be positive 250 meters here. But what we have to understand here is, it is positive because displacement is in the direction of force.
Yeah.
Final displacement is in the direction of force. That's why the final work is also positive. So this is what we can infer from these two cases. Like this is the best thing to understand how work is actually acting. You always have to understand all the physical quantities which we have learned so far. All of them will be used somewhat in these questions. Is it clear?
Yeah.
All right, let's move to another question.
Actually, can I see the previous slide one more time?
Yeah.
Okay, got it.
So the question is, there is an object of 10 kgs of mass. It was moving with 10 meters per second of velocity in the forward direction. Question is, find work done, sorry, find force due to which work done is 100 joules. You have to find out the force because of which the work done is going to be 100 joules. Think about it and tell me. What should be the force acting here so that work done is going to be 100 joules? This is what you have to answer. Also, one more thing is not mentioned here is the displacement. So how much displacement it is going to perform, this is also it is not mentioned here. Let me just give you one thing. The acceleration which the force reduces is 2 meters per second square. Apart from this, also find displacement.
Mm,
It is going to be pretty simple now.
okay. And the displacement 25. I mean 5.
Hmm. Displacement is going to be 5 meters.
And
So force can be calculated by mass times acceleration. Mass is 10, acceleration is 2. It is going to be 20 meters per second square. Work is nothing but force times displacement. So displacement is going to be work done upon force. Work done is supposed to be 100 joules. Force is 20 meters, 20 newtons. So the displacement is going to be 5 joules, 5 meters.
yes.
That's it. Now let's try to find out what is given in the second question. Think about the next one. You have given that there is a cyclist and he's capable of exerting a 50 newtons of force and he rides 251 meters in 30 seconds. Question is what is the work done in the given case, as well as you have to find the velocity after 30 seconds. At how much velocity the cyclist will have after 30 seconds. So this is also you have to understand.
Okay. Do we need the mass of the cyclist, or can it be solved without it?
Yes, we can try it out.
Oh, okay. I got the work done is 3,765 joules.
How did you find it?
I used the work equals F times S times cosine theta.
Yeah, so it is going to be 15 times 251, which is
Yeah, 3,765. What's in the
3765.
yeah 3,765?
So we got work here. Now the question says, what is the final velocity after 30 seconds? So what is the
Yeah.
final velocity after 30 seconds? How can you find that? By simply using equations of motion.
Okay. So you can use S equals BOT plus at 1/2 times 8 times T squared.
Yes.
Okay. That means so acceleration is 15 uh meters per second squared. Wait, no, it's 15 divided by m. So that's
Yeah, so we need the mass of the cycle as well. What we can assume here is, assume the mass of the cycle is supposed to be 20 kgs.
okay.
So if you assume the mass of cycle to be 20 kg, you get the acceleration, you'll substitute the values, and you take equations of motion, that is second equation of motion, and you're done with it.
Okay. That's nine, 19.62.
Yeah, that's fine.
Okay.
Let's move to another question. The next question we have here is, all right, so you can try it out. Question number 67 from the assignment you have given.
Oh, okay.
Yeah, so there's a person who has a mass of 52 kg. She rides up an escalator at Ocean Park in Hong Kong. This is the world's longest escalator with a length of 227 meters. So you have given an escalator, and the escalator is at an inclination of 31 degrees, and the length is 227 meters. It is the biggest escalator. Question is, how much work does the escalator do on that given person? So you have to find out work done by escalator on given person. Think about it, what it is going to be. Because here is the escalator, which is actually pulling the whole person upward.
Yeah.
So think about it, how can we do this?
Well, you need to find the vertical height first.
Yes.
I know you need to do sine theta, but when you multiply, you just multiply that with 227.
Mm, kind
Sine.
of.
Okay.
Yeah, let us try to understand what exactly is happening here. So suppose this is a person and it is going up like that. So what are the forces acting here? That is the first thing we have to observe here. So first thing it is acting here is mg. So mg is going to be the force against which this accelerator is pulling this whole person upward. So this is the force against which this accelerator is doing work. Apart from this, if we talk about the displacement from the initial and final position along or away from the direction of mg, it is going to be this height. So if the length of the accelerator is 227 meters, you can simply say that this length is going to be 227 sine 31 degrees.
Yeah.
Like this is what? This is the displacement.
Okay.
And the force is acting in the downward direction. Now look at the object again. So displacement is taking place in this direction. Force is acting in this direction. So work is going to be Fs. F here is mg times s. So mass is 52. G is what? 9.8.
Mm-hmm.
And it is going to be Fs cos 180. What is displacement? 227 times sine 31. You just have to put all the values, and whatever you're getting, it is going to be the work. In this case, again, you'll be observing that work is going to be negative because work is done against the gravity. So if you're talking about the work done by the escalator, it is going to be positive. If you have to find out the work done by the gravity, it is ultimately going to be negative. So negative is representing work done by gravity.
Yeah.
Because we have chosen the forces this way. Whereas if we have to find out the work done by the escalator, it is going to be positive. Because escalator is doing work in the opposite direction as that of direction of motion of the escalator. Or you can say it is acting in the opposite direction of gravity, so work done by the escalator is going to be positive. So solve it and tell me what it is going to be.
Yeah. Wait. 46,738.
46,000. All right. 46,700
And 38.75.
So if you have to find the work done by escalator, it is going to be positive. Similarly, if you have to find work done by gravity, it is going to be negative of this. So just remember this particular point, that work is always calculated for the force. Either the force is in the direction of displacement, or either this force is going to be in the opposite direction of displacement. So both the cases are equally important as well as valid. So now what you can do is you can try out question number 70 from that same
All right.
worksheet. So Mary Cruz slides a 60 kg crate up an inclined ramp that is 2 meters long and attached to a platform 1 meters above the floor, as shown in the figure. A force 400 newtons parallel to the ramp is needed to slide the crate up the ramp at a constant speed. So when a 400 newtons of force is acting, in the upward direction, this crate moves with a constant velocity. Question is, how much work does Mary Cruz do in sliding the crate up the ramp? So how much work he's going to do? This is what we have to find. Again, the distance from here to here is 2 meters, whereas the vertical height is about 1 meters. Can you find out this angle using these two values, 2 meters and 1 meter?
Uh, yeah,
So just find it out and tell me what should be the angle of inclination first.
30.
Yeah, correct. So we got the angle here. That theta is going to be 30 degrees. As angle is 30 degrees, now let us try to draw the FBD in order to understand how many forces are acting here and what force is actually responsible for this thing, for this particular motion to execute. Like for example, straight is moving upward, so the force in the upward direction is 400 newtons, whereas the force in the downward direction is going to be mg. They can mark it as mg only. So apart from this, there is a normal force must be acting in this direction, that is perpendicular to the inclined plane. Angle of inclination is 30 degree. We already found this. Now, apart from this 400 newtons, what is the force acting here? There
Mm,
must be some force acting in the downward direction, which is going to be mg sine 30 degree,
well,
right? Whereas in this direction, mg cos 30 degrees acting. So what we have already studied here is that this normal and this mg sine mg cos 30 will cancel out each other. So they will not play any role in any work. So the force which is actually taking place here, it is mg sine 30 in downward direction and 400 newtons in upward direction. So this is acting in downward direction.
yeah,
It is acting in upward direction. The question says that because of this 400 newtons force, the object moves with constant velocity. Now just think about it and I try to answer. If we have to find out the work done by the person to slide the crate up the ramp, what exactly or against which force that person is actually pulling that, or you can say pushing that object upward. What should be the force against which it is going to push that object upward?
the same force. So, uh,
Same force what?
like the same amount of force that's making it go down. That's to they have to apply the greater than mg sine 30.
Yeah, we should say this, that work is being done against mg sine 30 degree. And work is done in such a way that object gets a constant velocity. So the force with which it is going upward is 400 newtons, and this is the force which is acting in the downward direction also. Then only it is possible. Let us try to find out the value of mg sine theta here. We'll get to know more about it. So m is supposed to be 60 kgs. So 60 times g, that is 9.8 times sine 30. Sine 30 is 1 by 2. So if you solve it, you'll get 30 times 9.8. So it is
Yeah,
going to be approximately 300. So the force in the downward direction is 300 newtons, and the force in the upward direction is 400 newtons. What does it mean? It means that there must be some other force as well apart from this friction, apart from this mg sine 30 and 400 newtons, and that force is going to be, I guess, frictional force. And when it is moving upward, friction force also going to act in the downward direction like that. So it's not our concern that whichever force is acting here and whichever is not. We have to find out the work, and work is simply going to be force times displacement. The force acting in the upward direction is to 400 newtons. The displacement in the upward direction, it is going to happen here, is 2 meters. The work done here is 800 joules. This is how simple it is. Like, this is how you're supposed to do this. But apart from this, you have to understand all the forces, because sometimes there are more than one forces is capable of doing the work in the game, same given question. So we have to find it out and think accordingly. The second part of the question says, how much work would be done if Marie Cruz simply lifted the crate straight up from the floor to the platform? So suppose if the crate is placed here and it just raised the same like that. So how much work she has to or he has to do? Again, the same case. Mg is acting in the downward direction, displacement is taking place in the upward direction. So work done in this case is going to be what? Mg times S and cos 180. So Mg is mass is given 60, 60 times 9.8, cos displacement is 1 meter, cos 180 is -1. So it is going to be almost 600 joules. So instead of sliding, if he or she just moved to the point of the platform directly by lifting it up without dragging it, so then he must have to do a little less work in comparison to the work which is done in this first case. As you can see the comparison also, in the first case it got to 800 joules, whereas in the second case it is simply 600 joules. How we got 600? Mass times g times the displacement, which is s, times cos of 180. So this is how you're supposed to do this particular question. Is it clear?
Yeah.
Sometimes we do feels like that the question is too long and will take time, but in most of the cases you'll find that you just have to be good with the concepts. You'll be able to do those questions quite easily. So
Okay.
try to do questions in that way. There are so many questions which involves power. We haven't discussed power yet. So in the coming classes when we discuss power, we'll be able to do most of them questions. And
Okay.
also just make sure you try maximum of these questions so that you'll have an idea, you'll have a good idea that how much you got from this particular topic. This is power. In the next class, we talk about energy. And energy is a good thing, is a big thing. We'll talk about it accordingly.
Okay.
All right, then let's keep it till here only. See you in the next class. Till then, keep solving as many numericals as you can.